Monitoring airport ground operations with Ultralytics YOLO 11 models is a very cool use case and can also have a very large impact. So in this video here, we're going to talk about some different use cases of how object detection, computer vision, especially the Ultralytics YOLO model, both for instance segmentation, tracking that you can run out of the box, like queue management and all that. We're going to cover some different use cases, some potential projects that you can look into if you want to build computer vision systems, get more experience, but also just use the Ultralytics YOLO models. If you jump straight into our blog post, we have blog posts covering pretty much anything you need to know in the computer vision space, all different use cases, everything is covered on our YouTube channel as well, and in the Ultralytics documentation. So make sure to check those out. Listen to the videos, watch the videos if you're more interested in that, but everything is covered in the blog post as well. So airports, there's tons of airports out there, tons of flights flying every single day. There's a lot of security in airports, and you have probably been to the airport waiting long time for your baggage, waiting long time in the security checks and all that, which can actually be optimized with computer vision, and already some airports are moving in that direction. For example, if you go to the security queues, some systems are actually directing people to different queues just based on a camera system. So it can detect how many people are in the individual queues for the security check, and then it can route people, say, go to line 9, go to line 4, and so on. This is actually just based on a computer vision system, detecting how many people are in each queue, calculating the queue time. So another cool thing here could be baggage counting, how many suitcases are going in and out on the conveyor belt when you have to pick it up. Could also be when you're transporting it to the plane, or basically just when you're checking in your luggage. All these things here can be used. You can just have a video, set it up, use the Ultralytics models directly out of the box. We already have videos covering some of the use cases, both how to run tracking. We have a queue management system where we actually do calculating how many people are in a specific queue. We're going over some of the details, implementation details on how you can do it. So what makes real-time airport monitoring a challenge? And it's basically just tons of people to operate, to manage. There's a lot of security measurements that needs to be taken into account. Everything is going pretty fast, and there's pretty much no room for errors. Just imagine if the luggage, if the bag, suitcase, and all that is not going on the right conveyor belt, some is missing their baggage and so on. It's not really a nice situation to be in, and you want to make it as efficient as possible because so many people are coming in and out of the airport. And if you've been to any airport in the whole world, pretty much all of them is very busy. And just a slight increase in the efficiency for the airport management can make it a much better experience, but also save a ton of cost and also just get more people through. So for example, here we have a pretty good visualization of airport ground operation challenges. So shift transition gaps and communication breakdowns, equipment misplacements, and clearance violations. Could also be detecting objects that shouldn't be there, like someone leaving baggage behind, or how long has this baggage been on the conveyor belt going around, so detect the specific bags and then maybe have someone move it. Ground crew safety and movement hazards, reduce visibility due to weather conditions, just coordination complexity. You can detect all the planes. You can use RNA bounding boxes if you have a satellite view. You can check what gates are free. All these things here, like how many people or how many planes are lined up on the runway. Tons of use cases in the airport industry. So here, for example, we have YOLO V11 for computer vision task. You can use instant segmentation, object tracking, track any objects around, track planes taking off, track people moving around in the airport, post estimation, or in bounding box detection. For example, on this image here, we can fit a bounding box around the planes. We can calculate how long does it take a plane to board, how long does it take a plane from it landed to it takes off, and all these things here can basically just feed into a analytics system that can do analytics, feed data, not necessarily do something active, but just provide insights into the operations at airports. So it could also be detecting baggage card, workers, airplanes in the image. A very cool use case is maybe not hard hats in the airport, but safety vests. Are the workers, safety workers, the airplane workers and all that, are they wearing safety vests when they're out there putting in the bags in the back of the airplane? All these safety measurements, they can be detected by just a single camera and then having an Ultralytics model running there. It's not really the code itself, it's just a few lines of code. As you know, with Ultralytics, we can use the models out of the box, run it. It's much more about the use cases. How do we build the use cases and business logic around it and get it out there into a real system? So ground crew safety, post-estimation, airport ground operation automation, so queue management system is a very cool one, and we have a full dedicated video going over all the details. We run it on the videos, we count how many are in the queues. You can also go in and calculate the queue time, how long is it taking to get through. This could be in the security area, this could be passport control. There's a lot of queues, there's a lot of waiting time in the airports, and if we can just make it a bit faster, a bit better user experience, I think that a lot of people will be way more happy, but also the just operations will be more efficient. Anomaly detection with AI, YOLO 11, if there's any like anomalies, any optics placed somewhere that it shouldn't be. So of course there's both pros and cons to using computer vision in airport security, like low operational disruptions, like scalable monitoring, data-driven decision making. So it's not really like doing something active, controlling something based on detections. It's much more about just getting more data, feed it into our system so we can make data-driven decisions, because we don't have cameras in airport just monitoring if people are wearing the required equipment, if the bags are going into the actual airplane. It just goes on the cart, they drive out, they put it in, but there's not really anything validating how many suitcases are going into the plane, how many were supposed to go into the plane. All these things here can feed into a system where you can go in and optimize the operations in airports. This is very cool use cases. Definitely check them out. Like if you're looking for a computer vision project, these are some very cool ones where you can learn how to implement like computer vision system end to end. And it's not only for just like learning projects, but this could actually like have very significant impact out in the real world. Have the models. The hardest part is getting out there in the real world, working, providing value for businesses and airports and so on. But it's relatively simple to get up and running. It's just about getting it out there running. We have videos covering every single thing that you need, from data, how to train your own custom models, apply the business logic, export them into a production ready framework where you can run significantly faster inference, how you connect it to cameras. All these things are covered. So there's some environment sensitivity, of course, in airport, like lighting conditions, weather can affect how the models operate and so on. There's camera placements. So for example, if we have a satellite image, might not be as easy to get access to. Camera placement, usually like high ceilings in airports, model training and customizations. So it varies a lot from airport to airport. We need to make the models basically just be very good at generalizing to the different environments and recognize the different optics. Another thing is just like personal like sensitivity, people walking around like getting tracked, they remove, they do and so on. But just behind the hood, tracking baggage, tracking queue management, all of these things here can feed into better decision, more efficient operations at the airports, but also much more user experience for all you guys out there when you go to an airport if they had all these camera-based systems. Hope you learned a ton in this video here. Check out the other videos that we have on the channel with the exact use cases here where we set up the projects fully end to end. And then I hope to see you guys in one of the upcoming videos. Until then, happy learning.